This is problem 1 of the physics exam. If you want to find the vector for each observation location, here's what you need. In order to find the x component of the vector, you need to multiply the radius by cosine of theta. And if you want to find the y component, you multiply the radius by sine of theta. And the z component will just end up being 0. So together, this gives you the vector for each observation location. In order to calculate the net electric field, you need to find both its x component and its y component. And because you need to find both, you need to have two r vectors, two r magnitudes, and two r hats. First, let's start with r vector. So you have r1, which will be your r vector for the electric field in the x component. And to calculate r1, you need the observation location minus the position of the first sphere. So you will have q1 dot pos. As for R2, similarly, it's obs location minus q2 dot pos. As for our magnitude, you need to do the square root of r1 dot x, which is the x component of r vector, and then you do squared plus r1 dot y, which is the y component of r1. You square that plus r1 dot z squared. And you do the same for R2. So essentially everything here is the same, except you replace R1 with R2. And as for R hat, of course you need one for R1 and R2. It would be R vector divided by R magnitude. Oops. Now that you've found all three R values, you are ready to calculate the components for the electric field. So you have E1, which is the x component, equal to the constants, which is UPES times the charge. Now you have times R1 hat divided by R1 mag squared. And same goes for the y component of the electric field. You have the constants times the charge times R2 hat divided by R2 mag squared. And so your net electric field would be E1 plus E2. Okay, so in order to create an arrow to display the net electric field at the observation location and scale it, you need to have EA, which represents the arrow for the electric field, equal to arrow. Position is equal to observation location. Your axis will be equal to the net electric field times the scale factor, and then the color will just be orange. Close them off, and that's it.